Welcome to the webinar support of CITS technologies in LISA. My name is Mario Krumnow, and I will guide you through this presentation. If you have any question during the presentation, you can ask them in our chat room, and my colleagues Anja Liebsche and Matthias Künzemann will try to answer them. Connected and automated vehicles will change our daily life. They will increase the safety of the road users. They will improve the comfort of the passengers, and with higher equipment rate, it will change the traffic flow on our streets. To support that kind of vehicles, it is important to share some information. This is information to extend the sensor range of this car. The keyword here is a local dynamic map, for example. And another thing is, especially for signalized intersections, this is a topology information about the connections of an intersection and the addicted signal groups, and of course the signal state of that signal groups. So for us, the most important messages here are the cooperative awareness message. This is the information from the car, which includes the position, the velocity, and the priority. For a priority management with a traffic light controller, here we have a signal request, a signal state message. And from the infrastructure, there is information about the topology, which is a map message, which includes the connections of the intersections together with the addicted signal groups. Reference to that message, we have a SPAT message, a signal phase and timing message, which includes a mandatory field. This is a current signal state. And of course, there's some optional fields, which includes the duration of the current signal phase with a min, max, and a likely value, which is important for actuated traffic lights. Here we have a traffic light with an installed roadside unit, which provides the information about the map and the SPAT. Then we have the vehicles with included an onboard unit, which is able to receive those kind of messages. And here we have the map message together with the GPS location of the car. So a map matching can be done. And together with the SPAT information, we gather information about the current signal light state, so we can have a lot of services like a red violation warning, a green light optimal speed advisory, and so on. And for the driver, we can have a user interfaces like a head-up display, where we can bring that information into a graphical interface, and the goal here is to optimize the fuel consumption and increase the driving comfort. In our view, a traffic light forecast is an essential part of this SPAT, and just to ensure the new services. And of course, over time, the intersection topology can be changed because of roadworks and so on. So we think that the map needs to be updated and of course maintained. In cases of automated vehicles, the safety and security of the communication technology has to be ensured. Today, the traffic management is really good. That means we have high quality traffic light signal controls available, which recognize every request of single traffic streams. We have a recomputation of green times in every single second, which means we have a high accuracy of adapted traffic light controls. We use public transport prioritizations. We use coordinations of arterial roads and of course networks. That means actuated signal controls are the reasons why very sophisticated signalized intersections can be managed. A first example here, you see on the image the green dot, which represents single induction loops. This measures the occupancy only at discrete points of the network. So a lot of assumptions are necessary just to get a fuel traffic model here. And we think with V2X communication, we can have a continuous measuring here. So we have a full traffic overview of that kind of area. So we have a complete detection of all the vehicles. The information flow in a vehicle to infrastructure communication, we have here the vehicle with the onboard unit, which shares the cam information, the cooperative awareness message, position, and the velocity is known by the traffic light, which receives that information by a roadside unit. And with a map matching, also a map matching here, we have a lane and the map match can message here. We have a demand, and we see the journey times and so on. So with the provided information here, we can have conventional. We can extend our conventional detectors and use that information in our actuated signal control. So a lot of new strategies are imaginable, and of course here the map needs to be managed. The generation of map messages in Lisa is very easy. You can make use of the fundamental information of your signal light control, which has to be very accurate because of the safety related information you compute in Lisa. So there is no additional effort. The only thing you have to do is to add a georeferenced coordinate to your topology, and then you can export a valid map message. After a map matching process in the roadside unit, every equipped vehicle is written to a list with some attributes. Here we have the target lane, the vehicle type, the distance to the stop line, a velocity, and the priority of the car. This information is based to a lot of new functions in our traffic light logic. The limitations we have today is in example 1, the requirements of green time. If we have discrete sensors like the induction loops here, we can only measure the occupancy at a specific place. That means even at low traffic demands, stops cannot be totally avoided, and we have additional waiting time here. By using the time gap criteria with discrete detectors, we can only interrupt the green times by measuring a time gap which is over a specific threshold. That means we cannot recognize platoons very precisely, so we cannot extend green times, especially for platoons. Next, I will show you how to improve the request of a signal phase. The typical way is to use an occupancy detector, which is installed directly in front of the stop line. So if a car reaches that induction loop, we have a request and the time we arrive at the stop line. That means we have additional waiting times here, which is exactly 10 seconds. To improve that behavior, we can also use the time gap detector, which is installed around 30 meters away from the stop line. So that means we have additional journey time to reach the stop line, and we can minimize the waiting time here. So here you see we have a request at second 0, our arrival in second 4, and the start of the green phase is in second 10. So we have additional 6-second waiting time. To optimize that, we can use car-to-X information. So if we recognize a car in our communication range, we can send a request at position 0. The green starts in second 10 and we have arrival in second 12. That means we have no waiting time here. Together with a closer interface in the car, we have a very nice cooperative system here. Next, I will show you how you can improve the extension of a signal phase. The idea here is to add another check to our time gap criteria. The first example here, you see that we have some recognized vehicles in the communication range of our roadside unit. And the idea here is to have a computation. This is very easy. This is the available green time of our controller divided by the recognized vehicles, and the result is a mean extension requirement per vehicle. And if this factor is below a specific threshold, we extend the green time of the signal control. With lower penetration rate, the same situation, the factor is over our threshold and we don't have a green extension here. So there are no disadvantages related to the penetration rate of the equipped vehicles. In general, unused green time means additional waiting time for other directions. If you want to have efficient distribution of green times, In general, unused green times means more or less additional waiting time for other directions. To have an efficient distribution of green times, information about the estimated time of arrival at the stop line, the traffic volume on the road, and the velocity on the road would be very fine. Also, pedestrians and bicyclists can publish CAN messages, which you can use in your signal light control. In overload situations, information about the queue length and the traffic demand would be very fine to handle that. And in our point of view, the conventional planning will be extended. It's more an evolution than a revolution. Currently, we develop a lot of new control methods based on the V2X technologies, which handles the informations of the CAN message, the traffic demand, the information about platoons, and so on, and the information of the map message, which means the topology, restriction, lengths, speed limits, and so on. So this is done with an additional library. We call it V2X Library, which can include in the LISA project, and you can use it directly in the signal logic to optimize that. Just to give an example how you can use the new V2X library in your signal control, here is an example of a time gap control with a time gap criteria here. So the time gap of detector D2_1 is higher than a threshold here. A Boolean variable is set to true, and then check if there is any equipped vehicle on the road with the attribute that the estimated time of arrival is below than 5 seconds. This Boolean value is resetted and the green phase is extended again. This is just a small example how you can use that. Now I will show you how you can extend your SPAT message with a traffic light forecast. In LISA, you can use a local prediction to do that. The forecast is included directly in the traffic light logic as an additional method as a subroutine. The advantage of that approach is that we have access to all the relevant control parameters of all the methods, and this is done in real time. Because there is no information exchange with external services, we don't have any latencies in the systems, and of course no need for external services. Because we want to support very highly actuated controls, we do a recomputation every cycle, which means every seconds. More or less important point is that the prediction is working directly after the installation for every supported timetables on the traffic light controller. In LISA, the signal logic is no black box. So that means we have access to all the decisions, restraints, and thresholds of the logic, the used variables and constants, and of course the signal times and detectors. All that unique information can be used for a prediction. After the compilation of the structures for the signal controller, we have information online for the internal variables, the input values like the detector states, the information of the public transport, and of course of the control method parameters. In LISA, the computation of the prediction is done after the finalization of the control logic, where we firstly check all the used variables, the threshold, the conditions, restraints, and so on. By running some mathematical stuff, we find the best fitting forecast solution for that unique signal control. By running various simulation scenarios, we check if the quality is high enough. Then we define appropriate prediction horizons, which is important for highly actuated traffic light controls. We considered all the signal states, not only the green and red ones, so we have red, amber, the blinking states, and so on. And we add the prediction code directly to the signal logic. So that means we have an extended logic in the end, which can be published directly to the traffic light controller. And the next major release of LISA, this is LISA 8, which comes up next year, you will see an extended test environment where you can test the prediction as well as all the V2X technologies by using virtual roadside unit. What are the tasks for the future, especially for traffic engineers? In our opinion, unique and complex traffic light logics won't be replaced. Maybe they get extended by new V2X technologies, but we think more it's the kind of an evolution than kind of a revolution. During the planning process, we think that the generation of map information will become standard in the future. We think that a traffic light forecast component could be very important if you can integrate it directly into the traffic light logic. the planning of communication devices is important just to reach a specific communication range. And because of the huge communication data you have, we think efficiently management is necessary here. And the requirements for the infrastructure here is we need hardware. This could be dedicated short-range communication like the Wi-Fi P, or of course cellular radio like UMTS, LTE, or the 5G networks. And of course, we need equipped vehicles with standardized communication units and which are able to broadcast readable CAN messages. So thank you very much for your attention.
Only have one question in the chat. So I think Mario already explained everything in his presentation. So there's only this one question about the VISM interface. As you might know, the LISA planning tool has its integrated simulation test site and also an interface to the VISM simulation tool. And the question was whether it's possible to simulate V2X vehicles also in VISM. So in the first step, it will be possible to do a simulation of V2X vehicles in the LISA test site, and to use these new library with the V2X functions within the LISA and to test the new controls. In the second step, of course, it's interesting to do this with the VISM simulation as well. But the current status is that there is no interface for these data in VISM available right now. But when this will be available, then of course we will update our LISA VISM interface to provide these data in VISM simulations as well.
Of course, the usage of different simulators will be planned for the future here, but the signal control is programmed directly in LISA, and if you have an interface to connect to your simulator, feel free to use it. Yeah.
There's another question from World.
So let's see the questions in the chat.
So you all can see these questions. The values the values are not available right now because it's still under in development. And these new information which are sent by the vehicles in LISA or later in the reality as well, they are available with the new OML library, as Mario explained. So yes, you will. They will be available for new plannings or new types, new kinds of traffic plannings when the OML, the new OML version is available.
Yeah. So in first step, you can simulate with that new library in LISA, see the effect, the level of service, for example, and the next step, if the supplier of the signal controllers implement the interfaces, we can send it directly to the traffic controller.
And there's another question, Mario, regarding the forecast. Rodrich asked, do you see the forecast code as a black box? So is it a sort of neural network that is generated automatically, or is it an extra logic that the traffic expert should design himself? I think you can explain this. Yeah.
Of course, the forecast is directly related to your logic, to the logic in LISA. That means we see all the variables and we see the effect during the simulations. We see the decisions, we see the constraints, and so on. And also we have the opportunity to use OML functions just to see if, for example, the public transport and how this is handled, and we can make use of all that functions. So we have a forecast which uses directly the constraint and the variables you use in your logic, and together with some information about the current state of the detectors. Of course, we need some assumptions here. We can have a traffic light forecast here. This is not really a forecast, but you can also add some more forecasts here, or just make more restrictions. We think about a lot of settings, how you can control that step from simulation to the forecast.
Yeah, thank you for that, Mario. Another question from Roderick again. It goes in the same direction as the question from Robert. The answer to the question, if these data are available or the new libraries available right now, the answer is it's in development, and it will be available in the next big LISA, the bigger LISA release. In the meantime, we will have smaller updates, but this will be available in LISA 8, version 8. Yeah. So I think you have to wait a bit for that.
But nevertheless, you can construct your logic right now, and just wait if you have that function, and you can simulate that.
Exactly. Okay.
Have some more questions?
So currently there are no new questions.
Okay. So thank you very much for your attention, and yeah, see you next time.
Thank you.
Bye.
Ciao.